Hi, my name is Lady Garzon and today I'm talking about BIM or Building Information Modeling. Many people think that BIM is a beautiful thing, a pretty 3D representation of a building for visualization purposes. But what BIM really is a work methodology that combines software, but not just Revit, a lot of software like design, planning, scheduling, procurement, FEA software, a lot of software. 3D virtual systems, I will explain them more in detail in the next slides, but fundamentally databases. Databases is the big data, the connection between other disciplines or stages of the project. So what these three elements do is they create a unique working environment. So we all work in a unique model. So unlike the way we do traditionally, where every discipline works on different model and then you have to talk to different person to do different task in a variety of software. When we try to gather all this data, that's when consistency problems arise. So now, what is the methodology or how's the way that BIM work? So we get data entry, so we got our model, we put dimensions, geometry, cost, etc. And that's when the BIM process happens, the transformation, and we get some results. So we get construction details, calculations, all the data that we need for in further stages of the project. Here at the bottom we see this graph is the representation of a project life cycle. We see that all the elements are working together and they sharing information, and that's why we have BIM in the middle. They are not separate entities. So in a constant way, information is shared, so because BIM actually organizes all the people, processes, and tools. So why we should use BIM? BIM is the natural evolution of technology. So from the drafting board to the first computer to the CAD era to now the materialization of CAD. So when we have every discipline working on different model and then we try to put all together in a single model, that's when clashes happen. There is a communication problem. So BIM is actually a methodology for collaboration. BIM is better than traditional CAD. In CAD, a line is just a line. But in BIM, every element actually has information embedded to it. So it has characteristics that can be used for another discipline. So say, for example, architectural has information that can be used for electrical or mechanical, and also for further stages of the project. So it facilitates all the planning, design, all the stages in the project, the communication basically. Okay, what are the dimensions of BIM, the virtual systems? So we get 2D and 3D is what most of us already know, the visualization part. So in software like Revit, we can integrate some information. Say, for example, we have a panel, we can embed information to it like cost, lead times, etc. that can then be used for further stages like 4D and 5D. 4D is actually the integration of a schedule. So if we have a lead time, that information is associated in a semi-automatic way, and then can be exported to software like Primavera or Microsoft project. Now we got 5D, BIM 5D, where we can add costs also in a semi-automatic way, and then that data can also be exported to other software, procurement, Excel, etc. There is even people in Spain that talk about BIM to dimension 21D. But right now in Australia we're talking about 4D and 5D integration. Okay, in conclusion, BIM is it facilitates collaboration between different disciplines and stages of a project. It helps to identify mistakes even before design stage, facilitates cost planning and monitoring, scheduling. It's very flexible and it's a communication engine. Helps with process control, and it reduces uncertainty which increases profit. BIM is currently discussed for only the building industry, but actually if well implemented it can be used for manufacturing industry and that's what we know as industry 4.0. Thank you.